Okay, so we're starting with our first topic of Year 10 Maths, which is going to be probability. So I'm going to go, let's just skip through to our notes and we're just going to go through this. So we're starting off with our key ideas. So with probability, we'll have a whole heap of different terms and different things that we need to know about. So we've got a trial. So that's a single experiment. So say if you were like, because all probability, it's like, what are the chances? What is it something going to happen, or probability? You'd see it in your stats, in your, when the horse racing the other week, what's the chances? That's how they work out how much money they'll pay out, because a good horse has a higher probability of winning and things like that. So the first one is a trial. So that would be like, say, one race of that horse. He's done one race, so then we get that out. Or if we were like going to roll the dice, and we rolled it once, we might going to roll it 10 times, but the first one, that's one trial. So then we have something like the sample space. The sample space is what it could be, like the outcome. So if we rolled the dice, if we've got a normal dice, we could get a 1, 2, 3, 4, 5, 6, okay? Say if it was the horse race, it depends on how many horses you had. If you had, 20 horses in the race, we'd have one, first to 20th, yeah, is the sample that is one of what they could. Okay, so then you have the outcome, so what actually happened. So, I might have rolled a 6. An event is a collection of favourable outcomes. So say for the horse racing, we want the horse to come first. So we might be saying, how many times did this horse come first in all of its races? So an event is what we want. Maybe when we're playing Yahtzee, we're rolling the dice, we want a 6 or something like that. Okay, now, if we have equal likely outcomes, so those two scenarios I've been talking about, the dice has an equal likelihood, doesn't it? Because it's just pretty even. The horse racing, maybe not, because it doesn't have equal likelihood, because maybe one horse is closer to the edge, that that's an advantage and things like that. So that one you probably won't see as much in this thing. So when we're going to we're looking at probability, and the probability is like the chance of something happen. And when you can work out a probability, it's a number between 0 and 1. So you can see if you have 0, you've got no chance, yeah? So no chance. There's absolutely, it's not going to happen, all right? And then 1 is 100% it's going to happen. So if you had a probability of 1, it's, that's, you're going to win it. They know for a fact. Okay, so it's going to be a probability. It will be at any number between 0 and 1. So if we're like a 0.5 probability, we're like a 50%, yeah, 50-50. So probabilities are written in decimals or they're written in fractions. So maybe we might write, what's 0.5 as a fraction? What if you've got 50% chance, what fraction is that? It's 5 over 10. You could say good, but can we simplify that to 1/2? Yeah? So we can write a probability in fraction as well, and we can write it in decimal. We we might want to just point out that a fraction is an exact answer. Yeah? So sometimes if we needed an exact answer, it won't come up, it'll come up in the future. A fraction is an exact answer. But you can write 0.5, you can write half, you can write 5 over 10 unless they said in its simplest form. All right? So let's go have a look at next thing. So we're going to look at different types. There's different types of probability. So theoretical probability is also known as expected probability. So it's like we would expect this to happen. So it means that there's equal likely chance. So when you're rolling a dice, that's theoretical probability, because do we think we've got equal chance of rolling a 1, 2, 3, 4, 5, 6, yeah? So in that, that's like an equal. So that's when we say, and the way we work out the probability is we'd say the favourable outcome. So if we want to put, let's put a little example here just so you know. So say we said we wanted a 6 on the dice. That would be our favourable outcome. So say we rolled it 10 times. So say we rolled dice 10 times 10. If we wanted a 6, we count how many 6s we got out of those 10 times. So the total number of outcomes is the 10, yeah, in our example. And then the 6 would be, this would be how many 6s we got. Does that make sense? So that's how we work out that probability. Then you have like experimental probability. That is like when we've done experiments. So you do that more in science. So you see, you might just observe something. So it may be like, you know, say the monkeys at the zoo, how many times do they bang their chest? So we're just studying them, you know, say we said over a month, daily over a month. So we were just studying and we're looking at the result of that and out of how many days we were looking at it, all right? So that's more experimental is probability. So the long run proportion is the experimental probability for a sufficiently large number of trials. So it just means in the long run, technically, theoretical probability and experimental probability should match up. Because if we rolled the dice, say we rolled the dice 6 times, the likelihood I rolled this dice 6 times, I should see the probability of me getting a 6 is 1 out of 6. So I should see at least 1. I might not see that. How many times have we played a game? Do we get a roll of a 6? We don't get it, do we? So that's experimental. Theoretical is what we should probably see, and experimental is what we observed. All right, so let's have a look. Let's go through. If we go through the questions, they're going to be a bit easier. So a coin is flipped. How many different outcomes are possible for a single coin flip? So I've got a coin. What do we say? What are the 2 options of the coin? Yeah, so how many options are there? 2. So good. We've got 2. What is the sample space for a coin? So we like to put these curly brackets and we put our sample space. So the sample space is what could I get? What are the options I could get? I could get what? A tail? Is that true? Or I could get a head. So that's my sample space. What are the possible outcomes equal likely? Yes, we do say this, and when we flip a coin, we say yes, it's equal. What is the probability of obtaining a tail? So if you think about it, probability of tail, let's put, if we did the form, the outcome we want to get 1 tail out of what are the total possible outcomes I have? I have 2, don't I? So would you say the probability is a half? Or what would be that as a decimal? 0.5? Would you go? 50% I get a tail? Okay, what is the probability of not obtaining a tail? So you get a head, obviously. What is the probability of that? Is it the same? Yes? The probability of not tail? That means I could get a head, which is there's only 1 option out of 2, so that's the same. What's the probability of obtaining a head or a tail? If I got either? 1. We're 100% going to get that. That's good. So the probability of head or tail is 1. It's absolutely going to happen. We're going to get one or the other for that. Okay. So here, let's have a look. We want to work out the probability of getting a 4 in this scenario. So this 4 is the favourable outcome. Okay? So when we go to do our probability of this, so the probability of a 4 in this scenario, there's only one 4 out of how many options? 4. So there's 4 outcomes. So if I look over here, the probability of a 4, there's only one, but how many options are there? There's 1, 2, how many pieces of... Yeah, there's 6. So that one's the probability of 6. What about this one? Now, the probability of 4, how many 4s are there? There's 3 there. There's 3 options out of how many total options? How many pieces are there? There. 8. So there's that one. And then what about this one? The probability of a 4. Is it 0? There's none there, is there? Okay, so that's all that we're doing. We're saying the probability of the 4 over that. Now, given a spinner has a probability of 1 out of 3 of spinning a 4, estimate how many 4s you could expect in 12 spins. So, if it's got a third, if every time you spin it, you've got a third of a chance of getting a 4. So a third of 12 spins. In maths, the word of actually means multiplication. So if I change that to thing, I want to know I'd get a third of 12 spins could be a 4. So if you do fractions, we could change that to 1. When we multiply fractions, we go across the top. So 1 times 12 is 12. And 3 times 1 is 3. So that simplifies down to 4. So if I had a spinner and I had a third of a chance of getting a 4, if I spinned it 4 times, I should actually see I should get it 4 of them because a third of 12 is 4. So if we do the same here, a third of 60, I change it again to times. Oh, sorry. It's because my little... Okay, and then we would end up with 60 over 3, which equals I should get 20. I should get 24s when I do that. And here, a third of 300. So, of always means times, so I could change that. And we get 300, so it would be 100. I should expect 100 4s if I had that chance. You can just divide. All right. So